All right. So two kinds of the material. So let's say I have iodine. So I have iodine. This is solid. So I have iodine pieces here, and I throw it here. So the iodine randomly oriented. So it doesn't matter how you put this iodine molecule. Yeah. So it could be like this. So there is no knowledge you need to put the molecular orientation in water. Yeah. Because they just dissolve it, and that's a non-electrolyte. Yeah, non-electrolyte. It doesn't break. So so this is this element here. So I show you here periodic table. So look this the brown element. So if your salt, if your material is from this brown element, so they are not going to break into any ions. So we can just throw there and we can put any way we like. Yeah. So these are all these brown elements here, and that hydrogen. They, if I put there in the water, I don't need to know how to draw their molecules there or particles there. Yeah, I can draw any way I like. Make sense? So so if you look the iodine here, iodine is right there. So right here, so this is a chlorine, bromine, iodine here. So all brown elements. So this is non-electrolyte. So it, although it dissolves, it doesn't break into ions. So I don't need any knowledge how I draw it. Make sense? Like that. So how about the glucose? So let's look the glucose. C6H12O6. So this is a glucose. So how I draw that molecule in water here again? So I put the glucose here and I stir it and dissolve. Do I need to know how to write the glucose there? So look again. So in glucose I have a C. That's a brown element there. C. Where is that? That is C there. And hydrogen, that's a brown element. Oxygen, that's a brown element from here, right? This one, so there is a carbon, so all brown element there, right? So it's a non-electrolyte. It doesn't break into ions. So if you in the compound, if you look all those brown elements there from there, it's a non-electrolyte. It's not going to conduct electricity. It's not going to break into ions. Make sense? So do I need to any knowledge to draw how this molecule oriented? I don't know. So I can just throw there and I don't need to know anything. Yeah? Make sense? Good. Now, how about this one? NaCl. So let's say this is water. This is water here. And I'm throwing there NaCl. So look here, Na and Cl, NaCl. Where is Na? So Na is somewhere here in the first group. Right here is the Na. Right here is the Na, right? And the Cl is from somewhere here. So these all blue elements are metal, and these orange elements are non-metal. So they are sitting there to give a salt. Make sense? So in such case, we need to take a little bit care how we draw the structure of the particle in water. Make sense? So like that. So Na is a plus and Cl is minus. I told you the front one always plus, the second one is always minus, right? Now, if I put this sodium chloride here and it dissolves, and let's say this is a sodium particle and this is a Cl minus particle. So there is a specific way the molecules are oriented here. So Na, so this is a NaCl, it's dissolved. How it is dissolved is there is water molecules like this H2O molecules. So oxygen has minus charge, hydrogen has plus charge. So actually water molecules structure is like this. So this guy is minus, this guy is plus. Make sense? So this is a special way these things are oriented. So what happens is that at the beginning they will not dissolve. The sodium and chlorine are tightly held together by certain ionic force, right? Plus is attracting minus. Now what happens is, so this water, so this oxygen of this water is going to surround this sodium like this. Make sense? Because sodium oxygen has minus, hydrogen has plus, right? So the minus of this water molecule surround the sodium plus, and that hydrogen are turning away from sodium and turning toward the chlorine like this. So oxygen here, H plus, oxygen here, H plus, like this. Make sense? Chlorine is minus, sodium is plus, so sodium is surrounded by minus of the water, H plus, so H plus, S plus here. Make sense? So this is the, we need to know how to draw the structure of the ionic compound when they dissolve in water. Make sense? So simple. Water has a negative head and positive head. So the negative head is going to surround this sodium, and the positive head are going to surround this chlorine. And then since you put the something here in between that force, they break and dissolve. Make sense? So for the ionic, when ionic compound dissolve in water, we need to know how to draw their orientation in water. Yeah, so this is in, you already practice in lab 4. If you have not, you will do so like that. So I was saying that here. Here, look here. So the sodium, all this sodium are surrounded by the red element. So the red element is where is that? So red. So this is sodium ion is surrounded by the red element. That red is oxygen here, and this tiny hydrogen are turning away from the sodium. And if you look here, that chlorine has a minus charge there. So toward minus, these hydrogen are oriented toward chlorine. Here also they are turning toward chlorine, and oxygen are turning away. So there is the force between sodium and chlorine is diminished, so that sodium and chlorine get separated. Make sense? Right. So that way. So let's talk about the electrolyte here. So how do you might have done some experiment, but you don't know whether something is a electrolyte or non-electrolyte. Electrolyte means conduct electricity, and non-electrolyte means it does not conduct electricity. Yeah. So sometimes you go to the laboratory and you do the experiment and you are expecting one result, it doesn't give that result. So how it is possible? It's not giving you the expected result. So you can just by looking this periodic table, you can tell a lot of things. So take any blue elements from here and take any red elements, orange element there, and make a compound. So, so let's make some compound here and see if something is electrolyte or not. So I'm going to pick one element from blue here. So I can pick anything here. I pick, let's say, what's there is a strontium, Sr, right? That's a Sr there. So Sr. Now I'm going to pick another element from this group here. Let's say I pick chlorine here. So SrCl, right? So I'm making the combining Sr and Cl, right? So Sr is in group 2. So I write 2 here. Chlorine is group 7. So I write -1 here. So 1 come here, 1 come here. So my compound is SrCl2. So I can buy this compound from market and it's solid. Make sense? And is this an electrolyte or not? If I dissolve this in water, will it conduct electricity? If I connect the battery and the light, the light gives the bulb gives the light? That's my question, right? So you just by looking it, you can easily say, oh, it's an electrolyte. Why? I'm combining one blue element with one orange element. So this must be an ionic compound. So this is the electrolyte. Make sense? So any blue element combining with any orange element there, and you put in water and it dissolves. The criteria to be electrolyted must dissolve. Yeah. So blue element combining with the blue element, that's metal, combining with non-metal, and I put this compound in water and it dissolves. If it dissolves, it must conduct electricity. That's electrolyte. Yeah. So you can easily know something is electrolyte or not. Yeah. Take any compound. So I take one compound from here. Let's say iron. That's iron there. So iron. And then I put another from the somewhere here. So let's say fluorine, Fe(F). So fluorine, let's say I write 2 here. So that is coming from the +2 here. That's -1 here. That goes here 1. I don't write that. So iron fluoride, I have that compound. Is it an electrolyte or not? If I dissolve in water and it dissolves, and does it conduct electricity or not? Of course it does, right? Because it has one blue element and one brown element. Make sense? See electrolyte. So I give a set of a compound in exam, and I ask you, which do you think is an electrolyte, which do you think is not an electrolyte? Make sense? So just look the blue and that one, and so it's electrolyte. So how about let's say one element here, something like this. So I have this compound. I put this compound in exam, CS3, CS2, OH. So is this the electrolyte or not? Does it conduct electricity when it dissolves in water, right? Now look the carbon, that's an orange element. Hydrogen, orange element. Carbon, orange, 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 all orange element. So there is no blue element there. So this is not electrolyte. It doesn't conduct electricity even though it dissolves in water. Make sense? Everybody got it? So only one compound that has all brown elements can conduct electricity, and that's a vinegar. Yeah. So the vinegar is like this: CS3 COOH. So anywhere you see something like this, CS3 COOH, so that conducts electricity. Make sense? So this guy, if you see some the brown element, non-metal, 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 but there is this kind of thing, COOH. So something like this, they conduct electricity. So if I put vinegar in water, it's going to break it here, and it gives a plus sign and minus 2 particles like that. Yeah. So CS3, I have one particle is CS3 COO minus, another particle is S plus. So this minus and this plus conduct the electricity. Make sense? Good. And there are very few. So all brown element containing material has are few, and they conduct electricity. So this is one, and I am going to write a couple of things here, and let's see. So some acid and some bases. So let's say some acid. So S2SO4. So this is a acid. So it also breaks in water. S2SO4. If there is acid, yeah. So acid. Let's look another element. So this is brown, right? All brown, but still this conduct electricity. This is the acid. It breaks into water. If you taste it, it tastes sour. Yeah. HCl, HBr. So something like this. So S3PO4. There are some elements. So they conduct the electricity, even though they are made up of all non-metal ions. Look here, hydrogen, hydrogen, hydrogen. Hydrogen. So something like this element conduct the compound conduct electricity. Yeah. Good. So they are acid. So there is a hydrogen combined with some non-metal. Hydrogen combined with some non-metal. Hydrogen combined with some non-metal, because they dissolve and give the ion. So if I put the HCl in water, it breaks here, and it gives the first one is plus, second one is minus. So conduct the electricity. So these ions help to conduct the electricity. Make sense? So if I break the S2SO4, so it gives H plus from here and SO4 from SO4 to 9. So that break that way and conduct. Yeah. Everybody got it? So some acid conduct electricity, and if there is a C, H, and O, so one is CS3 COOH. You see the double O there, and one is those kind of compound connected, other terms. So let's put here. And I told you all these elements combining the blue element, combining with the you see the blue element combining with the orange element, and you put in water, and if those dissolve, definitely that's it, right? They conduct. Yeah. Good. So again, the same thing. So we are just defining these terms and with the same example. So I already told you this kind of compound. So this kind of compound. So let's say you put 100 gram of CS3COH in water. So only about 0.5 gram gets dissolved. Yeah. Other 99.5 gram does not dissolve. Right. I mean does not break. Dissolve but does not break. So this one. So weak electrolyte, so this kind of thing. So you look here, CS3COOH, CS3COH. So this is a vinegar, and if you put, let's say, 100 particles, 100 molecules of this in liquid here, only 5 molecules out of 100 molecules, only 5 molecules break here to give CS3COO minus and H plus. Very few molecules break, and 99.5 molecule don't break. 99.5% of the molecule don't break. So they are called weak electrolyte. Why they call weak? Because very small amount gets break. Huh? Yeah.
Let's swing it around.
Most of them don't break.
It's gonna swing around, huh?
Electrolyte. Now let's look here. Strong electrolyte. So strong electrolyte meaning that I put S2SO4 or this kind of thing, and or I told you the blue element versus the so we have water here. So I take the Na, which is a blue element, that's metal, and I have a chlorine, that's a orange element, non-metal. So if I throw it here, no matter how much I throw there, they completely break. If I put 100 molecules, all 100 molecules break and give Na plus Cl minus in water. Make sense? So I have 100 molecules, I put 100 molecules here in water, all 100 NaCl molecules break to give 100 sodium plus and 100 chlorine plus. 100 chlorine plus. Make sense? But in that case, when acetic acid, I put 100 molecule here, only 0.5, 0.5 break, and other 99.5 did not. Make sense? So something, it's very hard to break into ions in water. They are called the weak electrolyte, and those, when I just put it, everything breaks and gives the ions. That's called strong. Yeah? So, like that. And there is an experiment. So we do this kind of experiment. In the old time, we used to this kind of experiment, but nowadays we have the tiny conductive probe. You already did in lab 4, so we just look the number. So this is called the conductivity measurement apparatus or something like that. So what we do here is, let's say I have a beaker here. I put some water and I put two electrodes. So this is a copper piece like this. Copper piece, you can put the iron, it doesn't matter, it's a metal, right? And then I connect a battery, I connect a bulb here, light bulb. So light bulb here. So I have water here, right? Now I have water here. Now I need to connect this to the electricity supply. So I connect this to the electric supply or the battery. It doesn't matter. You either connect in the wall or you do whatever. Now, if something like this, and I put the sodium, so at the beginning I have only water here. So this is not, it doesn't give the light, meaning that the pure water does not have ions to conduct the electricity, so that doesn't give any light. Make sense? Got it? Yeah, so I have only water here, and I am connecting this water supply. Sorry, maybe I just have to put this another way. Let me put this another way here. So I connect this way here, and I put the battery here, plus and minus, and so it doesn't matter how we put there. So it doesn't conduct the electricity. But if I put a tiny bit salt here, it's going to give the iron, and it immediately the bulb is alight. Yeah. And if I put the strong electrolyte, then you will see the very bright light with that bulb. Yeah. And if you put the acetic acid, the light of that bulb is very faint. Yeah. So a long time ago, when we did not have the apparatus, we used to test the material like this. So I have a water in a beaker. I connect those with the battery and the bulb, and I put with the water. No light bulb doesn't give any light. And then I put a little bit sodium chloride. I would get a very bright light there. So that's a strong electrolyte. I would put acetic acid a little bit. I would get the light, but the light is faint. Yeah. So meaning that something that completely dissociates, 100% dissociates, that they have a lot of ions there and they conduct a lot of electricity. Easy? So we have this one. And the non-electrolyte, they don't conduct electricity, like the glucose, sugar, alcohols, iolate, all the brown elements contain CHO, so they don't break and they don't conduct electricity in water. Alrighty, so let's go to the another here. So that apparatus I'm going to show you here. Yeah. So the definition are here. So electrolyte versus non-electrolyte. So what is electrolyte? Electrolyte conduct electric current. So simple. What is electrolyte? Electrolyte means that solution conduct electricity. For example, lithium is a blue element, Cl is a brown element. So that's a compound containing metal and non-metal. So I throw in water, it conducts electricity, right? So how about here? So if I put that there, Li break and give the Li plus, Cl minus, so they conduct electricity. How about weak electrolyte? Very few molecules break to give ions. So for example, the compound containing something like this, COOH. Yeah, so only this kind of the molecules are the weak electrolyte. And when I put 100 molecule there, about 0.5% break, 99.5% don't break. And so they are weak electrolyte. And the non-electrolyte, they don't break and into ions. They don't give any ions, so they don't conduct electricity in water. So this is the alcohol. Iodine, so the iodine, and so they don't conduct electricity. So that is the conductivity apparatus I was saying. So look here. So this is the conductivity apparatus. So this is a beaker. So you put 2 electrodes. So maybe can be copper. So this is copper, and you are connecting with the battery here, or the wall, the electricity in the wall here, and you have a very this is ethanol. So you have water and you put some ethanol with ethyl alcohol, right? CS3, CS2, OS. So that's the drinking alcohol. So CS3, CS2, OS. All brown elements here. And you look here, it's not giving the light. And though we are passing the electricity, and here is the water and the ethanol there, so they are not bringing the electricity to the bulb there. So it's non-conductor. So this is not the electrolyte. Yeah, because that makes sense. I'm sending the electricity, but electricity is not passing through the side. Yeah. Now let's look at another one here. This one, we put the potassium chloride here, and then now you can see immediately the bulb is giving the light, right? Potassium is the blue element, and the Cl is the brown element. So blue element is the metal. This is a non-metal. So when I put the potassium chloride in water, it's going to break like this: K plus and Cl minus. So like this, right? And the K plus moves toward the negative part of the electrode, and Cl moves toward the positive. Look here. So this one is a this is positive electrode, this is negative electrode. So this positive part is going toward negative, and negative part is going toward the positive. So this negative part is going toward the positive part is going toward the negative. Yeah. So in the picture like this, it is hard to say which is negative or which is positive, because it's coming from the wall, right? But I easily say with the battery which one is positive or which one is negative. For example, if I was connecting that with the battery, so this guy and this guy with the battery. So let's say I have this battery here. So you can say, oh, this is a plus, this is minus, right? So battery has a plus and minus written already there. So if I connect this here, so this becomes the positive. I connect it here, this becomes the negative, right? But if the electricity is coming from the plus, something like this, from which whole the plus is coming. Which is a plus, which is minus, is very hard to tell with the plot. Make sense? Right? So the plus ion moves toward the minus electrode, minus ion moves toward the plus electrode when it is connected to the electrode. Yeah, and in the very beginning, I told you atom is electrically neutral. If I don't have the K plus or Cl minus, but if I have value like this, K atom. So if I have a K atom, it will not move either way because that's electrically neutral. Yeah. So I put that in homework. An atom is electrically neutral, meaning that it doesn't move toward positive or doesn't move toward negative. But K plus is the ion, because that's a cation, the positive. So that positive will move toward the negative. So I connect this here, so that will go toward this way. So K plus will go toward the minus, and Cl minus will go toward the plus. And it conduct the electricity. Make sense? It's very important. All our devices, for the batteries, they work in this principle. So I used to work in the battery research several years, so I do this kind of thing. Now another one. So this one is the dim lights. Look, the last one, dim light. So what do they put here? They put the dim light, acetic acid. So acetic acid is the vinegar. Vinegar is called acetic acid. So the acetic acid is this guy, CS3, COOS. So this is an acetic acid. So if you have a COOS type of material element here, they are going to break here to give plus here and minus here. So these are the weak electrolytes. So you take the water, you put some of those material. 99.5% of this vinegar is not going to break. only 0.5% are going to break to give CH3CO minus and H plus, and they help to conduct electricity very small. Yeah, so they are the lazy kind of fellow, right? Make sense? So NaCl, I told you, strong electrolyte. So what is a strong electrolyte? So look the blue element and combine that with the orange element, and anything that dissolves in water, they are the strong electrolyte. So they really give the bright light in the experiment. Make sense? Or if you are using the lab 4, we use the conductivity probe there, so it gives a very big number there. Yeah, strong electrolyte gives very big number. So I just tell you the blue element combined with all those blue elements combined with like for example, the blue element is sodium and you combine with the fluorine. The blue element is metal, non-metal, right? It's strong electrolyte. It is easy to see. So you put in water and they always 100% breaking water. Yeah, and they really give a bright light when I do that experiment. So how about the next one? Some acid and some bases. So again, here, so the Na is a blue element, OH is a non-metal there. So if I put those NaOH in water, NaOH, so I break them here, Na plus and OH minus. So they break completely. So I put in water and they break in Na plus and OH and they conduct electricity very high. Yeah. So I told you some of these things. So this is blue, this is blue, this is this is orange, this is orange, this is all these elements you see here. These are the made up of all non-metal, right? All orange elements, right? But although they are the orange element, they are the acid. So you test it and they taste sour. Yeah, they taste sour means that they break. So how they break is like this. So let's say you have the HCl. So you test it, it's sour. Why it becomes sour is that it breaks here and it gives H plus and Cl minus. So this guy tastes sour. Yeah, H plus gives taste to the tongue. That's the sour in taste. Yeah, so it breaks to give those ions. So this is very strong. Yeah, so if you put HCl in water and you connect with the battery and the bulb, it's going to give a very bright light. Again, this one is also acid. So if something that has hydrogen here and combine with the non-metal here, so it's going to break here and gives H plus and SO4 minus. HI. So like the HI, HBr, so HI. So here, if you see here, if I put in water, it's break like this. Yeah. So the first thing is you are looking the blue element and brown element combined, all are electrolyte. And second thing is you are looking the C, H, and O, and all the CHO compound are non-electrolyte, except having COOH. And then you are looking the H combined with the some brown elements like HI, SPSO4, HNO3, and that's make sense? Yes. And NaOH. So there are some other weak electrolytes, very sometimes they appear in the textbook. So this is called the carbonic acid, and this is called the ammonia, and this is the phosphoric acid. So they are all weak electrolytes, right? If I put them in water, they break a tiny bit, maybe 0.5%, maybe 1%, right? They don't break 100%. Now let's go here. Non-electrolyte. I already told you to make up of C, H, and O. So all these kind of compound or such compound. There is no hydrogen and all brown. This is brown, this is brown, this is brown, this is brown. All brown. So there is no COOH. So this kind of thing all are non-electrolyte. Can you identify electrolyte and non-electrolyte now? Yeah, just this piece, guys. Yeah. So we are just looking one whether the bond is light or bond is not. Yeah, or it either it gives a strong light or it gives a dim light. Yeah. So let's look this one. Reaction in aqueous solution. So what is aqueous solution? So aqueous solution means in water. We are doing the reaction. So some people do reaction in oil or organic compound, but we are doing the reaction in water. So I have a water in a cup and I throw there whatever I want to react, and those reactions are called aqueous reaction. Make sense? Reaction in aqueous medium. So I have a beaker, I put water first, and I want to do some reaction in that water medium, right? So those reactions are called aqueous, the reaction in aqueous medium. Aqueous medium. Make sense? So some people in future, if you go there, some organic chemistry people also do reaction in other media like alcohol. So they have alcohol in beaker, and they throw their material there, and also they do the reaction. But here we are doing the reaction in water. Ions. So difference between the ions and molecules. Ions have plus and minus charge. Molecules don't have charge. So for example, let's write something. So NaCl. So if I throw this into water, so it's going to break it here, and first is Na plus, and second one is Cl minus. So this kind of material, this kind of species are called ions, right? So the ions, this is called cations. So cation, because it has a plus, so plus we call cation, and the next one has a minus, so we call this as anion. Yeah, makes sense? It's just like the male and female, right? So one is moving one way, another is moving another. So and the molecules. So molecules don't have charge. For example, some molecules have charge, but most of the molecules don't have charge. So for example, CS3, CS2, CS3, CS2OS. So where is charge here? I can't see any charge here. Is plus here? I don't think so. So if I put this one, there is no charge. It neither move toward the positively charged electron nor negatively charged electron. It just sit there. It's electrically neutral, just like the atom. Yeah, it is not moving either way. So they don't have charge. Molecules don't have charge. They have charge. So when I put that there, they break, and one have plus and another have minus. So from a reaction, three things can happen: either precipitate forms, or gas evolve, or they say the weak electrolyte forms. So let's see what does that mean. So in water, the first one is, this is the very the famous term in chemistry, we call precipitate. Let's say I have water here. So this is water. So water here, and I have let's say silver nitrate solution here, very clear. So silver nitrate, AgNO3, silver nitrate, right? And I have, let's say, hydrochloric acid. Some I have in another one. I have hydrochloric acid. So here I have HCl. So some HCl here. So you see here, you don't see anything. It's just like the liquid water, right? And you see here, there's nothing. It looks completely like the water. Only is one thing. Make sense? Now I'm going to throw these two together, because this in the water here, and when I mix, I put that one here and that one here, and I will see a white solid here. I just mix these two there, and I saw the white solid there. Make sense? So this is called precipitate. Precipitate. Good? Precipitate. So precipitate. So how does that precipitate from here? So we'll discuss it a lot later. So I just show you an example here. So I was doing AgNO3, and I was reacting with the HCl like this. And what happened is, so this is one entity, this is another entity, and this is one entity, this is another entity, right? And then what I do is, this guy go and sit here, and this guy go and sit here, like this. So Ag, with Ag, previously there was nitrate, NO3. Now Cl goes and sit there, like this. And then this is hydrogen, and nitrate form and sit here as plus HNO3, like this. HNO3. So this guy now doesn't dissolve in water. Make sense? So this guy dissolve in water, this guy dissolve in water. When I mix them, they form this one and this one. This dissolve in water, but this does not dissolve in water. So it appears solid. Yeah? Something doesn't dissolve, appears solid, right? Right. That's called precipitate. Now the gas formation. So sometimes we form the gas. So for example, you react the sodium with sodium, Na is a metal, and you react with the HCl, acid. So this is the sodium. Since we have a H with some brown elements, it means the acid. Yeah. And then what happens is, this guy is going to combine with this guy, NaCl combine together and give salt, and this hydrogen they are going to displace out like the hydrogen gas. So gas forming reaction. Make sense? So sometimes you have a carbonate. So we'll discuss this reaction one by one later. So let's say you have carbonate here. Let's say I write the Na2CO3. So and I throw this into acid, and what happens is this. This Na is going to sit with the Cl, NaCl, and then from this carbonate you are going to get carbon dioxide like this, carbon dioxide. Yeah, and then maybe I produce some water also there with HNO. Make sense? So you see here, I produce a gas. Yeah. So don't worry about that last one. The formation of the weak electrolyte, we even don't get that one. So let's look here. What kind of the compound are soluble in water, and what kind of compound are not soluble in water? So it's just a prediction. So you look the periodic table and predict whether some salt are soluble or not. So how to read this chart? So I have even better chart than this one. So this is from our book. So I'm going to show you here. So let's say you have almost all salts of Na plus and ammonia. So let's say Na. So the Na is my Na plus is my one ion in my compound. Now put together this with something else here. Maybe you want to combine this Cl. Maybe you want to combine this with the Br. Maybe you want to combine this with the another, maybe Na2O. So something like this. If you see Na there, almost all of the material are soluble in water. Make sense? That's what it is saying. Yeah. So another one, potassium. Look the potassium. Almost all sort of Na. If you see this Na there in a compound, that salt definitely dissolved in water. If you see something K plus in the compound, let's say I write the K 2SO4, something like. Now I see this one, I even don't K this one. Now almost all salt containing K are soluble in water. Make sense? So I put there and you dissolve it. If you dissolve it, definitely the electrolyte, right? This one is a blue element, this one is a orange element, and it dissolves in water. That means that this definitely is a strong electrolyte. It gives a bright light in my experiment. Yeah? So that's what that's saying. Now, and same with the ammonia. So you see, you look in the compound, so you see somewhere like, let's say, ammonium, NH4, and something is connected with this guy. Oh yes, let's see. Is this an electrolyte or not electrolyte? Electrolyte. Immediately dissolve in water. Yeah, just by looking that front guy, you are saying that, oh, my compound is soluble in water. And if I do the experiment, it's going to give me a large, bright light. Yeah? Everybody got it? How about looking the second one? Look the second one, NO3. So NO3. I'm not looking the front one, I just look the second one. So let's say I have something like this. CuNO3. NO3. So my first one, there is no NA, that there is nothing here, Cu. So but look here the second one, NO3, right? And my table chart says if there is NO3, all material is soluble. So in the first, I was looking the first element and I predicted that it is soluble. Now I am looking the second entity there, and my chart says, oh, if you have an NO3 in that compound is also soluble. Make sense? That's what it is. Just by looking one ion, you are predicting whether it is soluble or not. Make sense? Look another one here. How about the ClO3 or ClO4 or CS3CO2? So let's say I write this one. For CS3COO or something like this. Look, just by looking this one, you say, oh, that compound is soluble, CS3COO. Yeah, I didn't look the first, I looked the second. In my chart, say, oh, you have the CS3CO, this one, and this one, and this one in behind. All those chemicals are going to dissolve in water. Everybody got it? It's a little bit confusing, but now let's go here. Are these, let's say if there is a Cl, Br, or I minus, all are dissolved. Let's say this one, I take one element from those blue. Let's say I take purple and then Cl. Will it dissolve or not dissolve? Let's say CuCl or CuCl2, I don't know, whatever there. is there. I have Cl in behind here. So that guy is saying that. So if you see Cl, all are going to dissolve. Make sense? And same with the Br. If you're going to see the Br, let's say I take the Mn and Br, two like this, something like this. I have a Br here, and I say, oh, this compound is going to dissolve. Yeah? Everybody got it? Yeah. And then how about here? Iodine. So let's say I have some barium iodide. So I put like this. Is it soluble or not soluble? Look here. Iodine is there. So if you see the iodine there, it's soluble. Yeah. But there are some exceptions. They don't dissolve. For example, Az. So if you put the Az and Cl, the exception meaning that like this. Az. I told you previously that all if you see here, this is Cl. So this is definitely going to dissolve. That's what I said, right? Now in this case, if you see Cl with sitting with Az, that's exception. It doesn't dissolve. Gives a place. Exception means that. Yeah. So let's look here. How about Hg2? Look, Hg2Cl, Hg2Br, Hg2I, they're sitting together, they don't dissolve. Yeah, exception means that. Or PV2Cl, PV2Br, PVI2, so they don't dissolve. PV sitting I does not dissolve. PV sitting with Br does not dissolve. PV sitting with Cl does not dissolve. Az sitting with Cl does not dissolve. Az sitting with Br, AzBr does not dissolve. Az sitting with I does not dissolve. Make sense? Exception means does not dissolve. Except this three, with these three elements, all material dissolve. How about Mn? I put MnCl, MnBr, Mni, all dissolve. Yeah? Got it? Or Ca, CaCl, CaBr, Cai. Yeah? So they all dissolve. So when it is these three salt don't dissolve with the Hg. How about this one? Salts of all here, right? We are talking here. The same thing here. Salt containing F. So all the material containing F is going to dissolve. But this fluoride don't dissolve. So if you see MgF, doesn't dissolve. If you see Ca sitting with F, doesn't dissolve. If you see Sr sitting with F, does not dissolve. Ba sitting with F, does not dissolve. Pb sitting with F, does not dissolve. All other F containing compound dissolve. Make sense? So let's write here. So I'm going to write here, let's say TIF4. So this compound, TIF4. Will this compound TIF4 dissolve in water or not? Does not dissolve in water. Now look at that. It is saying all material containing fluoride will dissolve in water except this. This is not Mg. Ti is not Mg, right? Ti is not Ca. Ti is not Sr. So this compound is going to dissolve in water. Make sense? Got it? A little bit confusing, right? Yeah. But I have another slide here that is even better. So here also, same thing. Calcium sulfate is not dissolving. Strontium sulfate not dissolving. Barium sulfate not dissolving. PbSO4 not dissolving. AgSO4 not dissolving. But all other SO4 are dissolving. So for example, I write here Na2SO4. So Na2. So is there Na? So no Na, no Na, no Na, no Na. So this is definitely dissolving. Make sense? So exception means something sitting with those don't dissolve. Yeah? So this one is CaSO4 don't dissolve, SrSO4 don't dissolve, BaSO4 don't dissolve, PbSO4 don't dissolve, AgSO4 don't dissolve, but all other SO4 dissolve. Yeah? FeSO4 dissolve, CaSO4 dissolve, right? Like that. Everybody got it? Just by looking this chart, I can say, oh, this is going to dissolve, so I can make this as my index. So I have 1 minute here. So let's look this one. How about this one? Most sort of this one don't dissolve. So look, anything with sitting with this material, carbonate, phosphate, oxalate, this one, they don't dissolve. But who dissolve? If this is a NS4 and an alkali metals cation. Alkali metal means the first group element, right? So they dissolve. So anything sitting with this, not dissolved, but any so they dissolve it. So we will talk in next class a little bit. Yeah. Okay. So I put another slide there so that is more easier than this one. Let's see.